Hey! Today we're going to do the integral test in calculus. More specifically, we're going to learn about the reasoning behind the integral test. So, there are two definitions that you should know before learning how to do this. The first thing is converging, or they are converging and diverging. Converging means that whatever is converging approaches a value, and diverging means that whatever is diverging does not approach a value. So basically, converging means that it approaches a value, and diverging means that it doesn't approach a value. So it approaches infinity or negative infinity. Okay, so let's get started here. So we can see that we have two graphs. On these graphs we have two lines here, both in black, and we can see that those would be our functions. Now, I know my artwork isn't great, but let's just say that those two lines are the same function. So in the first one, and let's say that this red is whatever we're adding. So in the first one, we have the series from n equals 1 to infinity of f of n. What does that mean? Well, that means that we have these points here. We have, let's say, x equals 1, 2, 3, and so on. And we have their corresponding y values here, 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 and so on. And basically what this is saying is we have our x value 1. We're going to find the y value, then add it to the y value of x equals 2. Then add that to the y value when x equals 3, and so on. So basically, we have to add up all the y values of the so we have to add up all these y values when x is an integer greater than or equal to 1. So how do we figure that out? Well, in this video, the more important question is how do we figure out whether this converges or diverges? Well, it's simple. We know that something similar to a series, in this case, is an integral. An integral tells us the entire area below this function. So here we would have the integral from 1 to infinity of f of x dx. So this integral will give us the entire area from 1 to infinity. But what we're looking for is just some specific areas. So what does that mean? Well, it means that this total area here, whatever we're trying to find here, would be this area, which is the total area under the graph, minus these values in between. So what does that mean? Well, it means that if this converges, if the integral converges, then this also converges. How? Well, if the integral converges, then this is approaching some finite value. So we can say that the area under the curve is a finite area. So a finite value minus some area, which is this area in between, will result in another finite area. So that means that therefore, this area, this sum, is also finite, which means that it converges. So let's write this out. Basically, if the integral from a to infinity of f of x dx converges, then the sum from n equals a to infinity of f of n also converges. If, however, this integral diverges, then this sum here also diverges. So that's basically it. That's all there is to know about the integral test. Thanks for watching.